safe. So I am the large language model called Dean. If I'm a little slow, it's just light speed delay. Don't worry about it. These are my prompts. So I'm going to talk about smart contracts. And is there a button to advance this? Oh, I just do it on here, right? Yeah. Okay, great. And artificial intelligence, and what the heck do they have to do with each other? First, I will start with a question. Here's the prompt for you. Who here has used a smart contract? Okay. What do you think a smart contract is? I worked on the first production smart contract in 1989, which it doesn't just predate blockchain, it actually predates the internet. So it is a contract, and ever since then, this has been the vision of smart contracts that evolved into what people are doing today, which is a contract-like arrangement expressed in code, source code, execution, where the behavior of the program enforces the terms of the contract. Nothing to do with blockchain, only a little bit to do with computers. In fact, it's all about the fact that you can have a system that is enforcing and orchestrating interaction between other components, other agents, other people. And so smart contracts were $1 trillion market cap before blockchain ever came along with eBay, PayPal. Well, now you have Airbnb, Uber, Lyft, high frequency trading, anything where there's software in the middle that the fundamental consequence of smart contracts is you're enabling cooperation among strangers, right? The rules of the game are enforced by the mechanism by which these participants are cooperating, and it's enforcing, okay, I saw that transaction go here, payment goes out, right? You're not allowed to say that, you're fired, you're fined, your collateral is consumed. Whatever the rules are, the software is enabling and enforcing that. Okay. So what did blockchain bring to the table? Because, $1 trillion market cap, that's a pretty big deal. What it does, so the gold standard of a blockchain is multiple independent computers that are managed by independent parties in different jurisdictions, all coming to consensus or agreement about what the state of the data is. Dean has $100 in his account. The order of events, Dean placed a bid and then withdrew it at the same time that the auction was closing. I can't both get my money back and win the bid, right? Because I either spend the money and win the auction, or I get my money back. So there's some order there. And so the outcome is the other thing that they come to consensus about. And it turns out that's pretty easy to do with one computer. Oh, I need to watch my time. I don't know. I will move on. The fundamental thing you get out of that is a level of computational integrity that did not exist before blockchain. Right? Because now no human organization or government in a properly decentralized system can corrupt the integrity of execution because they will be detected. You have to hit all of the participants or a majority of the participants simultaneously in order to corrupt the execution. And that's a big deal. That's a big improvement over let's just trust Intel to run this stuff in their enclave. It'll be fine. Right? Okay. What does this have to do with AIs? We have a lot of systems for enabling cooperation. And a lot of our work, a lot of Agoric's work, our foundation, Decentralized Cooperation Foundation, is about software enabling more kinds of cooperation. But what are these systems like? Okay, so let's just take legal contracts. The text of that is prose, right? I write up the contract. The threat is an adversarial one, right? Yes, we want to enable cooperation, but the concern is writing things so that if there's a dispute, it gets resolved. The gate, I meant to call this the enforcement, there's not actual sort of upfront, you can't do this thing. There's only after the fact enforcement and a challenge afterwards of this didn't work out right, I'm going to take you to court. Or lawyers are going to, as I've got a contract, a lawyer tests it to go, is this the right thing? Does this accomplish our goals? In the event of a dispute 10 years from now, is this going to work? But it's very soft and squishy. It's not strong enforcement before you even get into an infrastructure where you're safe. With conventional software, you have something almost similar, right? It's all expressed in code. It's mostly conventionally, right? When you looked at the 70s and 80s and how they teach people initially for software, it's considered benign. You're trying to get the software to do a thing, but you're not generally programming against a model of strong adversaries coming at your software. And you've got mechanisms that give you safety properties that improve the quality of your code, improve its robustness against accidental problems, and oh, by the way, some maliciousness. And the thing about type safety is if it's done right, it's a real enforcement. You can't express something in that particular environment that violates type safety and have it work. And so that's a gatekeeping function. This program that isn't type safe doesn't get to play. But let's say you've got something that's type safe, it still might not do what you want or what you expect. And so you have tests, you have reviewers, and evolved since then, software has moved into secure development life cycles and that sort of thing, where now you've got stronger things, especially on the challenge side. You're in a more adversarial world, and you've got stronger things where you're doing static analysis, where you're doing pen testing, all those kinds of stuff. And the extreme of that is exactly this world of smart contracts, where you've got code, it's adversarial, you've got multiple interests, and you want properties like, okay, if I give you my money, I got 1 minute? Okay. All right, I've got 2 more rows and then I'm done. If I give you my money, I want back, I either want to get my money back or get what I wanted, right? I will give you this money if you give me that painting. I either get the painting or my money back. And I want to not trust the code at the other end. I want the infrastructure to provide that safety property for me. And that takes off the table, just like with type safety, it takes off the table a whole bunch of bugs that might otherwise be a problem. There are additional mechanisms like testing and so forth to improve that security, but the thing about the gate is that's the rules that cannot be compromised by the participants in the system. So with the AI world, you've got the conventional thing, which is, again, right now, AIs are smart, but they're too stupid to really, get interests of their own and start going off in random strange directions. And you can protect against a lot of that with some of the things that people are doing now. But where we want to get to is where you've got super intelligences. It's deployed as a system, and that's where smart contracts come in. Because when you have an infrastructure that enables you to participate, to safely cooperate with strangers. They used to say on the internet, no one knows whether you're a dog. Well, in this kind of environment, no one knows whether you're a dog or a super intelligence. You still, I either get what I want or I get my money back. I've got some assurance by the infrastructure that we are operating in that you will be constrained to playing by the rules of the game. And this is a thing that we need to get out sooner rather than later, so we get to this world where it's not just talking to one giant superintelligence. It's a network of these things representing different interests, cooperating and competing with each other in such a way that I've got rules of the game that we can have the assurances that we care about when we're interacting with these possibly superintelligent, other counterparties, which may or may not be adversaries. And so that's where this comes in. So that's what the smart contracts and AI are important for the future.
Questions, comments?
Levi over there? Okay.
Could you say something about how this looks in implementation? So if we have ChatGPT right now, where would smart contracts insert?
So a big place where this shows up in implementation is how, ChatGPT is sort of, a general, AI, right? But at the point where I've got a doctor that has patient data and an analytics site that has proprietary model information, and neither one wants to disclose that thing to the other, they might want to use a deployment facility where they're going to submit this and they can get a diagnosis out without the secrets being leaked to either side. Okay, but now that doctor has an AI of their own that's doing general analytics, and it wants to be able to go, I've got some clue that maybe looking deeper into possible heart conditions is a good thing. That, as an agent, will go out and buy time of this more advanced, more specific, more narrow medical thing that can take that data and figure out what are the kinds of heart conditions and what more might you want to do here. And so you want to be able to have these AI agents that have, general purpose or, sort of some specific role, be able to subcontract out to more specialized agents that they are different because they've got proprietary models that they don't want to share with each other. And in some sense, that's a hopeful future because it generates this reason to have these different levels of intelligence that are all able to introspect on the outcome of each other, right? When it gets back a diagnosis from this specialized thing, that general thing ought to be able to understand the diagnosis and verify it, even if they could not have produced it in the first place.
Right. Thank you so much, team. Let's leave it at that.